The next talk, Professor Christos Athanassiou will be the next presenter. He's going to talk about innovative methods of disinfection in Agricultural Cooperatives Union of Aeghion. Dr. Athanassiou is collaborating for about 10 years with the Agricultural Cooperatives Union. Professor Athanassiou has been a consultant to several companies, and he has spent a lot of time of his research in the United States with USDA and some industries in the United States and also in Greece. And he's specializing on the disinfection of stored products. Mr. Athanassiou, Professor Athanassiou, thank you for being with us.
Okay, thank you, Vaios. Good morning, everybody, or good afternoon, or good evening, wherever you are. Let me share my screen. All right. Okay. Do you see my screen?
Yes, Christos, yes.
Probably yes. All right. So let me, I would like to give you a very, very brief overview of what we have been doing all those years with pests, with Panegyalios, with store currants and different other types of dried fruit. And I'm not going to be talking only about the use of nitrogen or the use of controlled or modified atmospheres, but I'm going to give you an overview of everything that we have done so far in terms of insect control. Let me start with the importance of phosphine. So whatever we do, we are still heavily rely on phosphine, which is a very important penetrative gas that we are using at the post-harvest stages of agricultural commodities, including dried fruits. So this is the main gas that is used for fumigation globally, not only in our case, not only in grains, not only in dried fruits, but also globally. And practically, we have no replacement of phosphine. So phosphine is a dominant insecticide. We never had in plant protection, in the history of plant protection products, an insecticide that is so widely adopted in so many cases of application scenarios, in so many commodities, in so many different structures. And the interesting thing with phosphine is, despite its high toxicity against insects, it leaves no residues, practically no residues on the product, on the commodity itself. This is why phosphine is dominant right now, and it's compatible with international trade. But there are a couple of drawbacks, shortcomings on the use of phosphine, like the development of resistance by many store product insects currently, and this is a global phenomenon right now. And phosphine needs, for sure, specialized personnel. So somebody has to go there and measure, somebody has to go there and add phosphine on the fumigated area. So this somebody has to be highly specialized. This is something that we do in pests and also in other industries as well. But this has to be performed by highly specialized personnel. So we make sure that the personnel that works with phosphine in a company like this pest, the current company, is highly trained by ourselves. So this means that since phosphine cannot cover us or our needs 100%, we need alternatives, because we have all those insect resistance cases. We have insect populations currently that are 2,000 times more resistant to phosphine in Australia, in China, now in Europe, and also in North America. So it becomes a very important issue right now, resistance development. You fumigate and nothing dies, or you have a very rapid rebound of the population right after the termination of the fumigation. And the other thing is that everybody's talking about food safety, but I quote here what Mario Nestle said some 15, 20 years ago, that if you want 100% food safety, you have to stop eating. So this means that we are some kind of an acrobats between zero tolerance in terms of insects and zero residues in terms of the use of insecticides. This is a very critical balance that we have to maintain. And the other thing is something that we do also with stored currants and dried fruits in general in Greece, is that we cover in its vast majority the demands of the organic food production. So we need alternatives that are directly compatible with the use of disinfestation of organic food. Practically, we need green insecticides. So those are some of the green methods that we have used in pests as alternatives to phosphine, to fumigation with phosphine. One is phosphine itself. We don't use phosphine anymore in the traditional way. We use phosphine in a very innovative way, working with sensors, remote monitoring. We have specific networks and platforms that indicate if your fumigation is successful or if it is not successful and needs to be refumigated. You need to reapply fumigation. The other things that we have done so far is extreme temperatures. And when I'm talking about extreme temperatures, I'm talking about heat and cold. So we have performed heat treatment in some cases or cold treatment in some other cases. I will elaborate a little bit more in the next slides. Modified atmospheres, which is the main topic in this specific webinar here. Novel insecticides with low mammalian toxicity, but very effective against insects. We have performed a lot of those trials as well here in Aeghion, and of course traps and pheromones, and not only traps for monitoring, not only traps to time the monitoring and time the application measures, but also traps and pheromones for mass trapping or pheromones for mating disruption. So we are using pheromones in this specific facility for insect control. Those are the alternatives that we have done so far: phosphine sensors, extreme temperatures, heat treatment, pheromones, mating disruption, modified atmospheres. So let me start with the first one. New insecticides. So everybody's using aerosols, everybody's using contact insecticides that you spray. But the issue here is that our areas, the food processing facilities, are not 2D. They are all 3D. It's not like you spray in the field or in an orchard or in a, let's say, you spray a cotton field or a wheat field where you have a 2D surface, 2D area that you have to cover. Here you have all those tiny areas with very complex machinery where insects can hide and can avoid the direct exposure to the insecticides. So we did a lot of experiments here, and this is what we have found so far. So regardless of the fact that we consider that we sprayed equally the entire structure, the entire facility, the entire area, processing area, the different colors here on the bottom of this slide indicate that there are different efficiencies, different efficacy levels according to the different areas that you have sprayed so far. So what we have learned so far from the sprayings, and we have adjusted the sprayings in this specific area accordingly, is we have learned 4 important things. 1, small droplet, low efficacy. You don't need to go with ULV anymore. No need to have aerosols with a very, very tiny, small, very, very tiny droplet. You lose efficacy. Number 2, airflow in the very beginning of the initiation of the application, in the very beginning of the application, is very beneficial, had a positive effect on the overall efficacy and the overall distribution of the spraying material. Airflow for longer periods, if you continue applying airflow, then you have a negative effect. You distribute the droplets wherever those are not needed, like in the walls, in the ceiling, but not where the insects are. And the most important is number 4, like most droplets eventually end up in the target within the first 10 to 15 minutes after the application. So this means that you have an immediate effect, but if you lose this immediate effect, you lose all your droplets right after that. So those are 4 critical points that need to be considered whenever you apply a contact insecticide. The phosphate